Okay, 2.2, polynomial functions of higher degree. You guys are going to be determining end behavior. Show me what end behavior looks with an even positive. Even positive. End behavior is up like this, yes? Okay, odd negative. Ends down, so it starts up.
Wait, what?
Odd negative. Ends down, so it started up. Okay? Now, we've been working with those a few times, so we're going to keep going with them.
Even negative.
Even negative does what? Down. What does an odd positive do? It ends up, so it starts down. Okay? So this is evidently not on widescreen. Okay, so graph the functions continuous and not continuous. A graph of polynomial is a continuous line. Yes? Is this continuous? No. So on the right, it is not a polynomial function. Not a polynomial function. It's not continuous. It is also a smooth curve. Here on the left. On the right, is that a smooth curve? No, that is an absolute value functions. Absolute value functions are not polynomials, and they are also considered discontinuous at the vertex because the slope is negative and positive. It is a sharp turn that is not considered continuous nor smooth, obviously. Yes?
Did you move those two tiles?
Oh, yes. It just says polynomial functions cannot have sharp turns. That's all it says. But I'm sorry about that. So polynomial functions, that's why when you guys graph and I get a parabola that looks like this, I'm like, no, that's not a parabola, is it? What should a parabola look like?
A U.
Okay, not perfect, but should it look like a U?
Yeah.
Yes. You should have continuous, smooth lines.
For the most part.
Okay. Any polynomial function, those are characteristics of it. Okay, powers. As my power, I have the gray is squared, is a quadratic. I have the dark, the black, is to the fourth. What do you think the eighth would look like?
It would go flat.
It would be more flat, wouldn't it? Now, is it really flat?
Yeah.
No, it just looks like it.
It just looks like it because it's really not touching. But are they all going to go through 1, 1?
Yeah. I don't like that.
Why? Because 1 to the 8th power is what? 1. Okay? So those are points that every even degree function will go through, correct? Until I start doing the plus, minus behind it. Okay? Look at the odd. Same thing happening there. The higher the degree, the flatter the line. Yep. Okay, so again, it is not constant down here. It does just touch at one point. But does it look like it from my picture?
Yes.
Yeah. And if you put it in your calculator, it would look like that. But if you kept zooming in, you could see that it does gradually come down. And again, it's the flatter it appears because it is not flat.
It looks very flat.
It looks very flat. Are we good? Okay. Now, end behavior, the leading coefficient test. There's a couple slides on here. I wouldn't take a ton of notes because I would only do arrows because that's all I ask from you. Now, in the book, if you read the answers, it's going to say as x approaches positive infinity, y approaches positive infinity, things like that. But I only care about the arrows. That's all I care about. Okay? So leading coefficient test only tells you where it starts and stops. Does not tell me anything in between.
What?
Okay, it does not tell me any behavior in between. That's why all of between it is dotted. These are two odd functions. Is the left positive or negative leading coefficient? Positive because it ends what? Up. So it starts down. Now, I'm okay with a positive leading coefficient. So A is greater than 0. If just putting ends up, so starts down. I'm okay with that. But if you want it in technical terms, it says as x approaches negative infinity, f of x, which also means what? Y approaches negative infinity. As x approaches positive infinity, y approaches positive infinity. Remember that arrow means approaches?
Yes.
Okay.
Can we just do f of x?
Yeah, you can do after that.
Can we just do arrows instead of the words?
No, that's
That's-
not what she
this-
said before.
This right there are all those words. I would put the symbols if I was going to put anything. I would not write those words. As x approaches positive or negative infinity, y approaches negative infinity. As x approaches positive infinity, y approaches positive infinity. Now on the right, is a less than 0 or greater than 0? Less than 0. How do I know it's less than 0?
Because it goes down.
It ends down, right? So it had to start up. So again, you could just do, I forgot my 0. You could just put the arrows. That's all I want on your assignment. I just want arrows. When you go to Calc Chat, they're going to have as x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y approaches negative infinity. They're going to have all the arrows, but you don't have to. All this is for us to do is get an idea what the graph looks like so we can find zeros. If I find zeros and I know how it ends and how it starts, can I draw a rough graph of this equation? Yes, that's all we need. So, do you think the thing is going to change any for even? Wait,
Yes.
you guys tell me when you're ready.
I'm ready.
Okay, this is it.
What?
For when it ends down, how does f of x approach infinity? Should it approach negative infinity as well?
No. When f of x is approaching negative infinity, y is approaching positive infinity. As x is approaching positive infinity, y is approaching negative infinity. So as I go further out on my x-axis, what is the graph doing? Does that make sense? I'm going further left on my graph, but my y's are going up. I'm going further right on my graph, and my y's are going down. Actually, what you visually see on a graph, for the most part, are your y's, because we just move naturally across our x-axis.
Should be switched instead of f of x approach positive infinity?
No.
No.
No, as x approaches positive infinity, f of x, which is y, approaches.
I didn't see that.
Yeah, they wrote it weird. I would write it the other way around. They wrote it in terms, they wrote y and x in terms of y instead of y in terms of x, which is weird. But I just copied their picture. I cheated. Callie, you good?
Yeah.
Okay. So now we have the even, and you guys already showed me your hands, right? Okay, as x approaches, when is a less than or greater than 0 in the first picture?
Greater than.
Greater than, how do you know?
Because
It never touches the.
It goes up.
There goes
So a is greater than 0, it goes what?
down.
I said greater than 0. Up. If a is less than 0, it goes what? Down. Okay. So again, I don't know why they wrote f of x approach it, because you always would talk about your x first. Don't have a clue. And again, the last thing again is it does not tell me any of the middle stuff, does it?
No.
The leading coefficient test only tells me the what? The end behavior. None of this doesn't tell me anything about this stuff. Just the end behavior. Kale, can you focus today and rather than distracting others?
Yeah.
Hey,
Please.
I think it might be Oscar's talking.
No, it's not.
Who's molesting my dog?
I'm watching it.
Yeah,
It's not.
But Miss Mick, I'm done.
What? If it's odd, it ends down, so it starts. If it's odd positive, it ends. Sorry, odd positive ends up, so it starts down. Odd negative ends down, so it starts up. Does that make sense what I'm saying? Okay. Questions about those, guys? It's going to ask you describe the end behavior. That's all you have to do. All I'm looking for is what? Arrows. Even on the test question, there is one test question.
There's only one question on the test.
Yep, one. It's worth 100 points. Okay, so describe the left hand, right hand behavior. Describe the end behavior. So first, is it odd or even? Odd. Oh, I did it. It's odd. And A is less than 0, so that means it ends down, so it has to start up. Odd or even on B?
Even.
Even, positive or negative?
Positive.
So even greater than 0, so it ends
Up.
up, up.
You're looking at the degree.
I do.
Yes,
Okay.
highest degree.
So,
And remember we talked the other day, no matter what, you need to put them in order. What's the correct order?
Highest degree,
Highest
lowest
to
degree.
Highest degree to lowest degree. So if it's not in order, you need to do what first?
Fix it.
Put it in order. Okay, odd or even? Odd. 5's odd. Positive or negative?
Positive.
Positive, so it ends up, so it started
Down.
down. Good?
no.
Good yet?
Yeah.
No, I'm still ready for the last one. What is the exponent?
5.
5. Okay, I'm ready.
Okay, zeros are polynomial functions. For a polynomial function of degree f, for a polynomial function f and a degree of n, f of x equals x of n. Okay, that's it. That's just description. The function f has at most n zeros. And it actually, they have exactly n zeros. But this should say, it should say what?
Real.
Real. It has, that fifth degree polynomial has exactly 5 zeros. Did I say real?
No.
No. Okay? They will have exactly whatever the degree is, but it doesn't mean they're all real. So if I have a fifth degree polynomial, can I have 7 zeros? No. I can only have the degree. I think there's more to this slide. Okay. The graph of f has at most n minus 1 turning points on the graph. So if I have x to the fifth, right? It has at most how many real zeros? 5 zeros. And I have 5, right? So let's see. If I were to sketch this, it's positive, so it's going to end up and start what?
Down.
Down. And it has to have n minus 1 turning points. So n is 5, so how many turning points am I going to have? 4. So I got to go 1, 2, 3, 4. Is that the only way it's going to end up back up? Yes. Okay. So you also can think of it as this way. I have 1, 2, 3, 4, 5. Yes? But how many turning points did I have?
4.
4. These are just things that are going to help us sketch a graph. We've done them all before. I just haven't said, this is it. They've happened. I just haven't told you they were happening.
It's not very nice.
I know. Oh, it went away. Okay, also, those turning points, we talked about them, are called relative, minimum, min, and max. Yes? Just so you know, they are relative. And why do we do relative now?
Because there's more than one.
There could be more than one. I don't know why that's green. There we go. And it's in red, and I'm going to tell you right now, the biggest thing you will ever do in math, no matter what math you're doing, is finding zeros.
Let's go.
Because zeros are the same as solutions, are the same as x-intercepts, yes?
Yeah.
Okay. Are we good on this slide?
Go.
Not yet.
Those things happen. We have the min and max, yes? And it also changes where it's what? Increasing to decreasing. So, and these are all things we've discussed. I've just now given you the actual rule on them.
the actual reasoning behind it.
Not reason, it's just the rule. I mean, I didn't give you any reason. I didn't tell you why. I just told you there was.
Well, why?
Am I good now? Okay. I think there's another thing there. Yep. Okay, repeated zeros. We talked about repeated zeros last year. Yes?
Yeah.
What happens at if k is odd? If your degree is odd, how many zeros is that? That'd be an odd number 0, right? It does what? Crosses. What about if your k is even?
Oh, then it doesn't.
It doesn't. It touches or bounces and goes back up or back down, correct? Okay. So this is just the repeated zeros, the multiplicity. Any even multiplicity, like x to the 4th. That's an even multiplicity, yes? It's going to hit it and bounce back up. X to the 5th, it's going to do what?
Bounce back up.
No, x to the 5th. It's going to go through it. It's like an open door, right? I open a door once, I can go through it. I touch it twice, that means it's closed. I'm going to bounce off if I run at it until I learn how to walk through objects.
This isn't Minecraft.
I know.
You have to twist the door handle.
I know.
Well, you just have
You
to
don't
interact
touch,
with
yes,
the
you
door.
have
You
to
don't.
just interact with it. You
Yes.
don't touch the door handle in Minecraft.
That's what I'm saying.
Pressure plate in front of it.
You have to
You don't
twist
have
the
to
door
do it.
handle.
Okay, focus.
This is it.
Okay, real numbers and properties of polynomials. Guys, this is nothing new. A 0 is a solution, is a factor. It comes from a factor and also is an x-intercept, yes? Okay, the only difference between these things, if I want a 0 of a function, I write what? X equals.
Zero.
If I want a solution of the function, I do what? X equals. If I want a factor, I just subtract it back over. Yes? If I want an x-intercept, I should always write it as a point. Do I find those things any differently? I set it equal to 0 and I factor. I set it equal to 0, I factor, I solve. I do them all the same way. The only difference is how I write them. I write a 0 and a solution exactly the same way, don't I? An x-intercept, I write as a what? Point. On your test, when you did not write it as a point, did you get all the points?
No.
No.
He's gonna write it.
Again, just reviewing things we knew already. The biggest part of your assignment is getting over what the directions are actually saying to you. That's the hardest part of the whole assignment. Because it's just this. You found zeros before, yes? Yeah, you've discussed end behavior before. So, Ethan, let me know when you're good. I think your last one writing. Isaiah, are you done?
Yeah.
Okay.
You good?
Okay. Okay, find all the zeros and graph. Okay, so first of all, odd or even? Even.
You look at the degree.
Even. And you know, technically this isn't algebraically even. We haven't done that. But the highest degree is even. And it's odd, so it's going to do what?
How is it?
You mean it's negative?
Not negative, not odd. Yeah, it can't, yeah.
Oh, it's so
Sorry.
even, but it's
I was
also
like,
odd. How is it odd?
That would make it neither, right? Okay, so it's even and negative, and the leading coefficient is negative, so it's down, down, yes? Okay, so we know we're good there. How do we find zeros? How do we find solutions? How do we find x-intercepts?
You can factor
I set it equal to 0 and factor, yes?
factor out of 2x squared.
How about a negative 2x squared?
That too.
Okay,
That too.
so 0 equals negative 2x squared. So that gives me x squared minus 1. Am I done factoring yet?
No.
Wait, yeah.
No.
Add over your 2.
Am I done factoring yet?
Can't turn the x minus 1 x plus.
We have a difference of squares right here, don't we?
Yeah.
So x minus 1 and x
Plus one.
plus 1. Now, since we are done factoring, we set them all equal to what? 0.
So
So the first one is going to give me what?
0.
0 with a multiplicity of what? 2. And I'm just going to put a times 2 up there. That means what's this graph going to do right there? It's going to bounce, right?
Wait, where'd you get the 0?
If you set this, I divide by 2, and I take the square root, yes? So I technically get plus or minus 0, but plus or minus 0 is just what? 0. Okay. So now what else?
Positive and negative 1.
Positive and negative 1, yes? So now I need to graph. And these are just sketches. If you go by ones, you don't have to tell me anything else. So it's going to go through negative 1, yes? And positive 1. What's it going to do at 0? Bounce.
But I thought it was down.
That's
I haven't done anything yet. It's still going to bounce.
Simply false.
Yeah.
So it's going to go, it's down, yes?
Yeah.
So it's going to start, bless you, down here, go up, come back down, and do what? Bounce, and then come back up, and go through that one, yes?
Yeah.
Looks like a lot of the ones that you had on this graphing thing that I still need to see if anybody wants. It's sitting right here. Okay, so do I know these maximums right here? No. That's calculus. We'll find the derivative. Oh, derivative's easy. Yep.
How easy is derivative? This sounds awfully difficult.
There. That's the derivative.
Like in me and Austin's terms.
No, that's the derivative. I just did it.
Alright, you multiple all by 2?
Nope, that's not what I did. But that's okay.
That's definitely what you did.
Nope.
No, that's definitely.
Okay, so then I would find the zeros of this.
She just.
How would it? No, I'm not telling you how I found it. I'd find the zeros of this. How would I find the zeros of this? Set it equal to 0 and factor out a negative 4.
Yeah.
X.
X.
And get 2x plus 1.
Yeah.
So I get x equals
X equals 0.
0 and negative 1/2.
Yeah.
Okay, so then I would go from there and that would tell me those and I'd plug in. It's all fun.
Why can't we know how to find it?
Because you don't need to.
Do we? Why not?
Because we're not
Because you don't
doing
need
it.
to focus on learning that one.
You need to learn PreCalc. Okay,
We can roll that.
so this is another way the directions are going to be listed. It's going to say use the leading coefficient test, find the zeros, and determine the multiplicity and the number of turning points. Did we just do all that?
Yes.
Yes. So just do what we did in our notes, right?
No.
Okay, is this function even or odd? Even.
That's odd. Or it's even, but it's negative.
It's even negative.
So I meant.
So it's even, and A is less than 0. So that means it's going to go what? Down, down. Okay, so I need to find the zeros. Am I going too fast? How do I find zeros? Set it equals 0. Hopefully everybody in this room would factor out a negative.
Nope.
I would have probably factored out a negative when I wrote it on my paper. Okay, so factors of 16 that add to 10.
But 8 and 2.
8 and 2.
You put
And there-
minus 10 on it?
I factored out a negative.
Yeah,
Okay, so it's going to be negative and then minus 2 and minus 8.
Yup.
So then my zeros, my zeros will be,
well, 0.
no,
Oh.
2 and 8. Okay, why? What's happening here? What number is right here? A 1. So it's 0 equals negative 1. Does 0 equal negative 1 without a variable? No. Okay, it's just a scalar. We've talked about scalars before. Negative 1 is just a scalar. So I have my zeros. My multiplicity, if your multiplicity is not more than 1, I don't care. You got it?
Yes, ma'am.
If it says discuss multiplicity and the multiplicity is 1, do you need to discuss it? No. Okay, am I ready to graph it?
Yes.
Oh, how many turning points am I going to have?
One.
We're going to have 1.
But how did you find it, that multiplicity?
N minus.
if there's more than one. Like if you had x minus 2 squared, that would be a multiplicity of what? 2. Because we would have 2 how many times? Twice. That's it. Okay, so there's one turning point, yes?
Yeah.
Because that was 2 minus 1. Okay, so I don't know why I put it so far down, but I did.
Is your follower?
Hello.
So 2 and 8. And no doubles, so it's going to go through and it's going to be down, down.
Yeah.
Now, we should be able to figure out the vertex of this if we wanted to.
But do we want to?
It's actually right somewhere up here. How did I know it's right there?
Because it has to be.
It has to be exactly in between your two. That's horrible. But it has to be exactly between your two zeros, yes? So if I wanted to plug in 5 to this problem and found out how high it was, could I do that?
Yeah.
Yeah.
Why did you do 2 minus 1?
What?
Why did you?
Because turning points are the degree minus 1. Questions other than that? Again, have we gone through this process before?
Yeah.
Yes.
No.
The directions are just going to make it sound like it's hard. Is it hard?
No.
Callie, are you good?
Yeah.
So did your multiplicity of 1 of the factors, but it's just
Yeah, there's just a degree of 1 here and here. Now, if I factored it again to x minus 2, that'd have a multiplicity of 2. If there was another x minus 2, it'd have a multiplicity of what? 3. That's it. Okay, do we need to do this again, guys?
No.
Okay. And again?
No, the only thing that.
Okay. Now, find the polynomial function. So I have zeros, yes?
Yeah.
So I need to go backwards. So where did zeros come from? Factors. So I need to make them into what? Factors. So it would be x equals 0 and x equals 8. Well, when I move this over, it becomes what?
So now it becomes negative 8.
X minus 8, yes. And this is just x, isn't it?
Yeah.
And then what do I do?
Multiply.
Multiply. I'm just going backwards, right? So f of x equals x squared minus 8x.
Got it.
Good job.
You guys want to try the next one on your own?
Yes.
Okay.
Whoever answered Hoover got the same answer I got.
What?
Whoever answered Hoover got the same answer I got.
Are you sure? Whatever answer Kale got, that's the same answer. I
Yeah.
got.
Yep. Actually, whatever answer Autumn got. It's the same answer.
Why don't you try it on your own?
Why can't I do something like that?
But you'll have to do it on your homework.
Jackson, you know, what's right there.
That's shocking.
Wow, I actually got it right. Where did you get the same answer that I did?
What'd you get for answer?
The same thing that's up on the board.
Okay, questions.
No.
Did everyone get that?
Yes.
Or getting there? Elena, you good?
No,
What happened?
I don't know.
Did you set it up this way right here?
Yeah.
Okay, so when you multiplied, did you get this when you multiplied?
I just completely skipped that.
I multiplied the x by the first one,
And then foiled? Oh, that would have been horrible.
I did x times x plus 4 and then multiplied that by x plus 5.
Oh, okay. Does it matter? What? I foiled these two and got this. And then I distributed the x. Because I can foil that in my head. Once you put a squared in there, for some reason, my brain doesn't want to work anymore. Did you find where you messed up?
Yeah.
Okay. So what if I said, like, you had to have, because this is a third degree, yes?
Yeah.
What if I said I wanted a fourth degree polynomial with just those zeros? What does that mean one of those zeros has to be? Squared. One of them has to be doubled. Could I square any of them?
Yeah.
Yeah. You know the easiest one to square?
No.
The hex.
That too.
Because all you'd have to do is put x squared, right?
Yo.
If I would have said, what if I said fifth degree? One of them, two of them could be squared, or I could just make this a x cubed. So is it, when you look in Calc Chat, they're going to say answers may vary. Okay? Because could I come up with infinite number of those things?
Yeah.
Yeah. Could I put a 5 in front of this x right here if I wanted to?
Yeah.
Yeah. It wouldn't change the zero, would it?
Zero.
It would have completely changed this polynomial, but would it change my zeros?
No.
No, because it's just a scalar. And now it's going to say fourth degree, but we're going to do this one. Probably not going to do this one because this one's pretty easy. We're going to do this one. X equals 9, but I want a third degree. So what do I have to do?
Yeah. You have to do the stuff.
What stuff?
It.
What's the factor for x equals 9?
X minus 9.
X minus 9. But how many times am I going to have x minus 9? 3. So that's x minus 9 times x minus 9 times what?
X minus 9.
Times. Nothing.
Brad, what do I get when I do this?
You got them there.
X squared minus 9x. No, minus 18x. Also start with the other kind of. And then that's it.
No?
You get oh wait, no, the minus 18 here.
Brad, what is 9 times 9?
What's negative 9 times negative 9?
It's 81.
It's 81 and it's positive, yes?
Yep.
So you foiled the first two and Brad got x squared minus 18x plus 81. Do you guys agree?
Yeah.
And then we multiply it by
X minus 9.
x minus 9.
I'm getting some huge numbers. That's supposed to do that.
Well, yeah, because you got 18 times 9. I mean,
Holy.
you're going to have 9 cubed going on there, too.
Is that first one supposed to be cubed?
Yeah.
I forget what 6 and 8 is. 14.
Anybody agree with me? I got x cubed minus 27x squared plus 243x minus 729.
Yep, that's exactly what I got.
That's what I got.
I believe it, Evan.
Okay.
Sounds close enough to me.
Now, the next one we're not going to do fully out, but we'll set it up. Okay? So if I have x equals negative 4, negative 1, 3, 6, and I only want a fourth degree, I just make what out of all those?
Just fact.
Just factors. So x plus 4 times x plus 1 times x minus 3 times x minus 6. How am I going to do this? I'm not going to do it. I'm going to multiply like the first two and the second two, and then I'm going to multiply them together. Or could I multiply the first two, then multiply by the third, then multiply by the fourth?
Yeah.
Yeah, whatever way, but can I multiply them all at one time?
No.
No. Okay,
I mean, you could.
you could, but you would get the wrong answer.
With a calculator, but.
No, I know. Well, not your calculators. Okay, questions, guys? Questions? I think that might be it. Oh, this is just a end. This is the end, I'm sure. Yes, I'll go back through it. Okay, so polynomial functions can change signs only at zeros. Yes, signs mean positive and negative, right? That only happens at real zeros because that's on the x-axis. Yes. Above is positive, below is what? Negative. What is it at the x-axis? Is it positive or negative? Is it positive? Is 0 positive or negative? No, it's neither. Okay, between two consecutive zeros, a polynomial must be either entirely positive or entirely negative. It cannot cross the x-axis unless I have a 0. That is a door, that is an open portal. Yes? If I don't have a door, can I go through the x-axis?
Yes.
No, I cannot. Okay, when real zeros of polynomial functions are put in order, when they are put in order, they divide the x-axis into intervals. Remember doing that last year? We will do it again this year. We're dividing that x-axis into intervals. Intervals between it was positive and negative. There's no sign change at the zeros again. Intervals are used for interval tests to determine the values of the polynomial function, whether it's positive or negative. You're not doing that today, but this is where we're going with all of this. This is why we are practicing it, because this is where we're going with it. We are going to be doing interval analysis again, so we will work on that. I do not expect you to go, oh, I know it. I do expect you to say, I remember doing this. Does that make sense what I'm getting at? Okay? So today leads up to what we're going towards at the end, and those are all our notes. So this is what I'm going to say on your assignment. I think 9 through 15 is just matching, okay? A, B, C, D. Okay, Brad, did it take you very long to do that homework assignment? No, I do not think, I think it's important for you guys to do all the problems because it's a review. I want to move on tomorrow. Do you think we can move on tomorrow?
No.
If there's lots of questions, we will definitely answer the questions tomorrow, but I would like to move. I don't want to spend a day in I don't think there's going to be that many questions. Just a second, I need to stop my recording.